Okay, so today's focus is on metals and non-metals. Okay, so some of the things we're going to look at today will include identifying metals and non-metals, so in everyday life, looking at the properties of metals and seeing what makes them unique, and also being able to describe what an alloy is and give a few examples of where we use alloys in everyday life. Okay, now, one of the activities that I'd often start off with here is this activity here, where you'd use the periodic table to assign the following as metals or non-metals. Okay. Um, Now, if we look here at our list of examples, there are elements and there appear to be compounds and molecules as well. Okay. So what we'll do here is we'll start off. We'll use our periodic table. Okay. If we look here at our periodic table, we can see that there is a division between metals and non-metals. Non-metals are to the right here of this ladder. So we have B, silicon, arsenic, going all the way here to the right. So all these green elements here are non-metals, okay, and these ones here as well are non-metals. So everything to the right here of this ladder here, if you want to think about this as a ladder, is a non-metal, okay? And everything to the left then, so everything that's remaining is actually a metal. So most of the elements of the periodic table are actually metals, even though, for example, you mightn't think of lithium or beryllium or magnesium being a metal, but actually in actual fact they are. Okay, so most of the periodic table is an element, is a metal rather. So if we look here at sodium, lithium, neon, okay, let's see if we can identify them. Sodium here is in group 1, it is a metal. Next one we had lithium. Was it lithium I said? Yes. So lithium is in group 1, it's a metal as well. If we look here at what I had a second ago, neon. Neon is over here somewhere. Yes, it's in group 8. It is a non-metal, so it's in the noble gases. Calcium and sulfur. So calcium is in group 2, so it's a non-metal. Sulfur is also, let's see, now sulfur here is a non-metal. You can see it over here on the non-metal side up to the right of this ladder. Okay, nitrogen and aluminium. So nitrogen is here, so it's a non-metal. Okay, and another one there, as I said, aluminium. Aluminium would be a metal. Now, can I find it? Yes, it's here, aluminium. We have mercury and chlorine. So chlorine is in group 7. It's a non-metal, but is mercury. So mercury should have the symbol Hg. Okay, mercury is a metal. Okay, and you'll find it there in your own time. We have a few other examples, which are diamonds, steel, and salt. Now, salt. So what we're seeing here are molecules. Okay, salt, steel, and diamond. So they wouldn't be. We can use our periodic table to help us with that, but you wouldn't consider diamond to be a metal. It is a compound of lots of carbon, pure carbon. Steel is a metal, so compounds can be metals as well, because steel is made of iron. Okay, and salt is NaCl, and this would not be considered a metal either. Okay, so the conclusion we can make about the quantities of metals and non-metals is that there are many more metals than there are non-metals. Okay, so skipping on. What we want to think about today are what are properties that make metals unique. Okay, so like if you picture a metal instrument, for example, like I don't know, like a tin whistle or a guitar that contain. If you think about the strings of the guitar, and you think about just metals in your house, for example, like the poker for the fire. What properties would make them different and individual and interesting? Okay, so the kind of things you might have mentioned there would be or things you would think about there might be the fact that if I use a poker for the fire, then you know that it's a good conductor of heat. So the heat will travel up the metal. Okay, you can think about that for a frying pan as well. The frying pan will get very hot. Okay, so it's a good conductor of heat and also a good conductor of electricity in general. Okay, so metals tend to be good conductors of electricity as well, like copper or wire. Another thing would be like, for example, if you think about like the strings of a guitar, okay, and when you strum the guitar, there would be like a kind of vibration created, and it's a very unique sound. Okay, if you hit a metal, it'll create a very unique sound, and that sound, we say it is a sonorous sound. Okay. If you think about metals as well, like and compare them to other like non-metals, metals tend to be quite shiny. Okay, like for example, like a lot of the awards you would receive are plated in gold or silver or bronze, and those because they are bright and shiny. Okay, so metals as well, it's very hard to melt them in general. Okay, we have to have a very high temperature to melt them. And another thing you might think about is the fact that we use it for construction because metals tend to be quite strong. Okay, so depends really on the metal that we use, but metals can be quite sturdy, especially things like steel. So what I'm going to ask you to do in your own time is check out this video. Okay, so this video here is physical properties of metals. Okay, and it will go through here some interesting properties about metals. Here it's I don't know, it's the BBC Productions maybe, but they have some really interesting stuff there that you can check out. Okay, about metals. So, having seen that video, it should really have reinforced the fact that metals have all these different properties, as I mentioned. They're good conductors of heat and electricity. They're shiny, like as I said for the awards. They're sonorous in that they make this unusual metal sound. One thing I didn't mention, but that's mentioned in the video, is that they're highly ductile. So ductile means that they can be stretched into long wires, and that's important when we're, you know, if you ever venture outside Dublin, you'll find that there's loads of animals and farming in Ireland, and it's really important to have fencing for those animals. And the fencing is basically electrified metals. You're talking about wire, okay, electrified wire, and this wire is ductile. It's been pulled into long strands that we can just, we can just attach the posts all the ways along the field to basically keep the sheep into the field. Okay. It also tends to be a good conductor of electricity. So if you just happen to walk along the countryside and by accident touch the wire, you're probably going to get shocked because this wire is basically conducting electricity all the time. So it's allowing electricity to go through it. Another thing that's interesting about metals as well is that they tend to be malleable, and that means that we can shape them into whatever shapes we want quite easily. Okay, so malleable means they can be shaped. So all of those are properties so far. And then if we talk about exceptions to the rules of metals that are unusual, okay? Now the obvious metal thing is like, what we've mentioned so far is like they are shiny, sonorous, good conductors, they're hard and they're strong like steel. But there's obviously exceptions to that rule, like for example, mercury. Mercury is a liquid metal, okay? And that would be an obvious example there, okay? So, like, these characteristics we're talking about will apply to most metals, but not all. Okay, then if we're talking about the non-metals, if you think about the non-metals on that periodic table again, and go back to what elements are on the right of that ladder, you can see oxygen, nitrogen, helium, neon, chlorine gas, okay, bromine. Most of those are actually gases. Okay, you look here at these; they're all gases here: helium, neon, argon. Okay, so what we can say about non-metals, if we're talking about non-metal elements, they tend to be gases. Okay, so they're gases. If we talk about other non-metals as well, you'll discover that a lot of them are liquids as well. And actually, what we tend to find is that they have opposite properties to metals. They tend to be poor conductors of electricity, so they don't allow electricity through too easily. They tend to be poor conductors of heat, so they insulate really well. Like, for example, wood is a poor conductor of heat. It will basically insulate your house. Okay. They have a low melting point. Okay. So that's another point to make there. And they tend to be brittle when they're solid. Okay. So skipping on. Um, Alloys. Now, alloys, it's very rare really that you go into a hardware store or whatever and you find a pure metal substance in front of you. It's very rare. Okay. What you're more likely to find is something we call an alloy. An alloy is just a mixture of metals. Okay. So we have we have melted down the metal, we have mixed it together and created this alloy. And it can be an alloy where there's like a plating of a particular metal on the outside, or different substance. Um, or they're generally just like impure substances. They're basically mixtures. Okay, so I'm just going to look at two different examples, like steel. Okay, steel is widely used in the construction sector. So every house and building across Ireland is made with steel, a certain amount of steel. And why is steel used opposed to just pure iron? Well, what you might know is that iron tends to rust. Okay, so if you leave iron out in the sunshine and the rain and all the weather really in Ireland, you will find that it'll start to gather rust and it'll start to go this rusty color. So obviously that's no good if this is holding up your house. So what we do instead is we use steel. Steel is basically a mixture of iron and carbon. Okay, so this carbon does not react with the atmosphere around it, and whereas the iron would. So the iron is on the inside and the carbon's on the outside, and it basically protects it from the elements there, and it doesn't rust. Okay, so steel is also beneficial as well in that it tends to be harder and stronger than iron. Okay, so therefore steel is really useful. Another one is stainless steel. So you have this kind of shiny, shiny cutlery drawer maybe at home with all your forks, knives, and spoons. And here you'll find the mixture of different metals again. So you're talking there about iron again. So iron is used in an awful lot of things. There's chromium and nickel as well used in this for your stainless steel. So if you have any stainless steel in your house, or stainless steel is used for an awful lot of things, but it's generally a mixture of iron, chromium, and nickel. Okay, brass instruments. Well, brass is not an actual element, but it is a mixture of copper and zinc. Okay, so all I expect you to know here is what an alloy is, that it's a mixture of metals, and know just two examples. I suggest you pick out mild steel. So steel is iron and carbon, and stainless steel there, iron, chromium, nickel. Right, can you answer these questions? So what I'm going to ask you to do is pause the video, have a go at these questions, and I will then call out the answers. Okay, so I'm going to call out the answers now. If I look at this here, we can see here that so if a good thermal property, so good thermal property basically means that it has, good thermal conductor basically means it can conduct heat well. The answer is it a metal or non-metal? The answer here would be metal. Okay, so you should have a tick here for metal. The next one, good electrical conductor, you'd also say metal. Okay, good thermal insulator, I would say non-metal. It does not conduct heat well, so therefore it's an insulator. Good electrical insulator, again, non-metals. Okay, it stands to reason actually here because a lot of plastics are used covering wires so that they insulate you and prevent you from getting shocked. Shiny, metals tend to be shiny, or lustrous is the technical term, lustrous. Dull, non-metals, they tend to be quite dull in color. Most are liquids or gases at room temperature. We said they are non-metals, and most are solid at room temperature. They are metals. Okay, name three metals and non-metals. So the three metals you could mention there would be like steel, iron. You could mention lithium. They're all metals. The non-metals, you could mention wood. You could mention neon, argon. So you could mention like a molecule, a substance, or you can mention an element. What term is used to describe the flexibility of metals? They are malleable. What term is used to describe the unique sound of metals? They are sonorous. Define an alloy. It's a mixture of metals. Why is mercury considered an exception to the general properties of metals? Mercury is a liquid, which is highly unusual for metals. What properties do diamonds share with metals? Well, diamonds tend to be very strong and hard, and they tend to be shiny. Okay, so just like metals. So, how is mild steel used? Can't read that question now. How is it superior to iron for construction? Because iron will rust and steel will not. Okay, right. So then, moving on, we want to look at I'm not going to look at the reactivity series. Right, I just want to have a look here at a rusting experiment if I have it. Yes. Okay, so one final thing that you should know about this chapter is that, about rust, okay, and how rusting works, what speeds it up, what's affecting it, and what rusting really is. So rusting relates here to the corrosion of iron. Okay, corrosion means it's wearing away. So this is rust here on this old Ferris wheel here. Okay, and what does that involve? Well, iron Fe on the periodic table reacts with oxygen, okay, in the atmosphere. And it reacts to create a compound we call FeO, which is iron oxide. And iron oxide is this rusty color here, okay? Now, iron oxide, in order to have rusting here, there's a few different conditions that actually can affect it. So if I was to set up an investigation on this, investigate the conditions necessary for rusting, there's a few things I could investigate. I could investigate like putting we'll say any metal object that is made of iron, pure iron, into a container, like for example a test tube. Okay, and I could expose it to water, so just water, and air. So we're not worrying about the oxygen levels inside here. I could expose it to, we'll say, boiled water, and now the idea of boiled water is that when you boil a liquid, what it does is it removes all the gases from it. So basically, there'd be no oxygen inside here. We put an oil layer to prevent any oxygen getting in. And in here, we have calcium chloride. So we've no water because calcium chloride absorbs the water and prevents it from getting on the nail. And if you did this experiment, what you'd do is you would allow the nails to sit in these test tubes for, we'll say, a week or two. And then you observe if there's any change in the appearance of the nail. What you're particularly interested in is looking for that rusty color. What you should find is that when the nail was exposed to water and air, that this one was rusted the most. Okay, so it was rusted the most because there was oxygen present inside here in the test tube, and there was water. And we know that water actually speeds up this process here of rusting, where oxygen bonds to the iron, creating iron oxide. We can also see here in this one that there was no rusting because oxygen wasn't present. If there's no oxygen, then there will be no iron oxide created. And finally, in this one here, there is oxygen, but there is no water. You might see a small amount of rust on this because oxygen will still bond with the iron, but just much slower because water is like a catalyst for this reaction. It speeds up the reaction. Okay, so what you'll do, guys, is read up a little bit about this in your book. The ways that we can prevent rusting is we can paint things. Like, for example, if you have a bike and there's a bit of rust in it, go away and paint it, because the paint will stop the oxygen binding with the iron on the bike. We can put a metal plating on it so that it doesn't rust, or we could simply put oil on it, and that will help prevent rust as well. Okay, so you do this all the time yourselves. Like if you're putting oil on your bike chain at home, then you are preventing rusting. If you have kitchenware which have a particular metal coating on them to prevent them from rusting, that would be an idea as well. Galvanized iron, so galvanizing there is again a type of plating that you put on the outside. And just painting the metal. So if you have metal furniture, again, you can paint it. So look, that's it for today. What you'll do is you'll check out the chapter in your book, Folens, on metals and non-metals. Read more about it there, okay? So your homework really today is simply going to be revise metals and non-metals based on what I said today, okay? Have a go at the questions at the end of the chapter, and that'll keep you going, okay? Talk to you later.